Hi guys, my name is Darren. Welcome to this video on gradient. I am, well, from mathsguru.com, believe it or not, which you can go over to and subscribe and sign up for free for these amazing videos. And there are a lot of them. And hopefully they're going to let you smash Year 9 maths. Now, again, subscribe. Please subscribe. The effort you take to click that little button in the corner hopefully is very, very little. But believe it or not, it actually tells me you're watching. That's it. No one watches maths videos. Everyone's off watching all sorts of other stuff, you know? People burning themselves by trying to do wood or whatever that stupid craze is at the moment. But just, I'm sitting in a room talking to myself, hopefully talking to you. Click that button, send it to your mates, tell them about this channel and get them to subscribe as well. And actually it makes me feel so happy. Sad, I know, I gotta get a life. Now, what are we dealing with today? We're going to deal with the previous videos. If you haven't watched them, they are there on mathsguru.com and YouTube. And I'm going to build on the idea of straight lines. We looked in the last video on horizontal lines, on vertical lines. We've looked at lines that go through the origin. And at the end of the video, I talked about concepts. I talked about something called the gradient, and I talked about something called the intercept. And again, this is leading up to something. Today's video, we're going to look at what the gradient is, and it's a measure of slope. Understand that it's a ratio between a vertical height and a horizontal change. Yeah, it's constant across a line. We'll come back to that. And the gradient is basically found from just 2 points on that line. So what we see here is, this is an example from previous, yeah? Every single one of these is different. They all have one thing in common. They go through the origin. And if you remember, the origin is the point in the middle and it has the coordinate 0, 0. And we love 0 as a number because it basically, you times anything by 0 and it's like, bye-bye, sayonara, be gone, ha-ha. Right? But what do we notice? Well, this line here seems to be sloping up. And this line here seems to be sloping up as well. But this one here has a very, very big slope. It seems to be much steeper than this line here. So do we have a way of quantifying that, making it into a number? This line here seems to be sloping in a different direction. So is there a way of telling a difference between the way a line slopes up and the way a line slopes down? Well, you would hope so. We're mathematicians. What else would this video be about? Shut up and keep going. Not you, me. That could have come over as rude. I didn't mean that. I'm sorry. So, gradient, as I said at the end of my previous video, is so important. Weirdly, in maths, we use the letter M for gradient. Now, my guys today said, well, why don't we use G, gravity? Why don't we use R, radians? Why don't we use A, acceleration? All the good letters have gone. And so, for some reason, Barry, yeah, thank you, Barry, said, let's choose M, that completely random letter that no one's going to remember or even understand. So M is gradient, or you can just write gradient. And we have decided it is a measure of how far across we go, given with how high we go. Now again, when I taught this to my kids today, I was like, what do you guys do first thing in the morning? And I'm like, no, don't tell me. No, really, stop. Whew. Okay, the first thing I do in the morning is I rise out of bed. Okay, and then what's the next thing you do? No, stop. Okay. Well, having got out of bed, I then go for a run. Actually, I don't go for a run. I can think of nothing worse than running, but each their own. I just use this as an idea that the gradient is rise divided by run. All right, some vertical getting up and down, some vertical change in height divided by some horizontal change. Now, gradient is a measure of steepness, and we can find it by choosing 2 points on my graph. More on that in just a moment. But it is important to realize that gradient basically can have 4 main values. That made no sense. I don't quite mean that. Basically, gradients can be positive. Now, positive gradients, when you read from left to right, will slope up. So gradients that slope up, when you look from left to right, I'll do it again, right? Slope up. Now these we say are positive gradients. There'll be a positive number. Numbers like 2 or 7 or 3/5. All of those numbers there are positive numbers. So they could be good examples of gradients. If you look here, I've provided you the equations of those lines. What I want you to do is look at the red line and this +2. Do you notice anything? Well, the red line happens to go through the y-axis at +2. What do we notice about the green line? Well, it's got a +1 at the end here. If we follow my green line back, where does it cross the y-axis? At +1. If we look at this number, this graph here, is there a number there? No, yes there is, it's +0. And does the blue one go through 0? It does. So we're already building this up. Can you see this? Now this stuff is amazing. But what about the numbers in front of the x's? We've got a 1 there, we've got a 2 there, we've got a 3 there. 1, 2 and 3. Different gradients, different slopes. Okay, so what about the next ones? Well, we've dealt with the positive ones. Now let's look at the negative ones. So again, when I read from left to right, if my graph slopes down, then we say it is a negative gradient. Minus VE just means negative in my rather strange mind. That's a negative gradient. And what we'll notice here is the numbers in front of the x's are all negative. -1, -2 and -3. And again, remember, if you've got y equals -x plus 2, there is a 1 there, so that's -1 times x. Should we just check that intercept thing again, check it's working? The red line, does it go through 2? I should cocoa. The green line, does it go through 1? I should cocoa. And does that one go through 0? It does. So I'm beginning to build up. Remember, I said in a previous video, if you have an intercept and a gradient, we can draw any line on the planet. Now, these are two special ones that you need to know. Horizontal lines have 0 gradient. We love it. I'd love to live in a country that's flat with a bike. It would be great. Thank you very much. Right? Then I'd get on a bike more often. Then I might even run. No, never going to run. Get on a bike. So each line here has a gradient equal to 0. M equals 0. M equals 0. M equals 0. Hold on a moment. That's the x-axis. But it's still a line. And this one here, M equals 0. So if you have a summary book or you just remember this stuff, any horizontal line has a gradient of 0. And I'll explain more why in a different video. What about vertical lines? Does that have a 0 gradient as well? No. Vertical lines, again, are special. The gradient of all vertical lines are basically undefined. And I'm going to explain why that is in, again, a little bit's time. But the gradient of that line is equal to undefined. The gradient of the blue line is, guess what? Undefined. And I'm just going to write undef, and the green line is also undef. So my gradient is undefined, undefined, undefined. There's not a shortcut. Write the word undefined. In the United Kingdom, we used to say the gradient is infinite, all right? And I'm not very good at drawing infinity signs, as you can see, all right? Some of your teachers may say that's okay. In Australia, I'm led to believe, and a lot of the calculators now will actually come up with the word undefined. So probably best to stick with convention. So let's go back to finding the gradient. How do you find the gradient? The first and most important thing to do is choose 2 points anywhere on that line. I'll explain why they can be anywhere on that line in a moment. But generally speaking, we choose it where there is a whole number coordinate. So if I look at this point here, that is on the line, that has a coordinate 0, 2. If I look at that point there, it has a whole number coordinate as 2, 4. Probably wouldn't choose this one here because it's not really on an exact coordinate value. But I could if I had really, really accurate graph paper. Having chosen those 2 coordinates, I want you to literally think you're driving along one-way streets, and I want you to join them by using a triangle. So there we go. There is a triangle. I've gone along and I've gone up. Hold on a moment. I go along by running, and when I rise, I get up. So what we should now know is that distance along the bottom there, that number of squares, is actually equal to my run. And that thing there, that height, is my rise, because height and rise mean exactly the same thing. So gradient is basically just some sort of measure of how many up I go in comparison to how many across I go. So the gradient of this line is equal to, right, so we want to do rise first. So if we look at this, I go across the landing. Now, My axes, as they go that way, get more positive, don't they? Yes? So if I'm heading that way, I must have gone 2 squares, plus 2. I've gone plus 2 along the bottom. Now, don't get tricked here. The run, that horizontal, is always on the bottom, as it says here. I'm now going up. And if we go up my axes, again, I get more positive. So I've gone up 2 squares. So my rise is 2 squares as well. Now, going back to those rules we've had in previous parts of maths, a positive and a positive and a negative and a negative, what do we know? They are a positive. So they effectively do not now need to be written. And I know what 2 divided by 2 is. It is 1. And so actually, I can now say the gradient of that line is equal to 1. What about if I chose a different 2 points? Well, let's choose this point here, and I'll go up to maybe this point here. Now again, if I go across until I'm level, and then up to meet that point, I'm going 2 that way, and I'm going up 2. So my gradient again is 2 divided by 2, or 1. It doesn't even matter if I go from this dot here to say this dot here. Let's do a different color. I can actually go up and across. It doesn't matter which way you go, so long as you write it into your formula properly. So let's see, I've gone up. So if I go up, that's a positive. So I've gone up 1, 2, 3, 4 squares. I'm going to the right, which is positive 1, 2, 3, 4 squares. And so again, my gradient would be 4 divided by 4, which is 1. And one of the things I said at the start of this lesson is the gradient along a straight line is the same regardless of which 2 points you use. And that sort of makes life a little bit easier for me. So let's have a look at these questions. Thank you very much to Cambridge for allowing me to use their questions. I am so grateful. Your textbooks rock. But for each graph, state whether the gradient is positive, negative, 0, or undefined, and then find the gradient where possible. Okay, so this first graph here I know is positive because it is sloping up. This one here is negative. It is sloping down. This one here has a 0 gradient. Why? Because horizontal lines have a 0 gradient, and this one here is undefined. Now I cannot find the gradient of an undefined, so we're going to leave that one there. But now let's go back to each of my examples to see if I find the gradient. Well, the gradient here I can automatically put down as 0 because it is 0. Okay, so the gradient there is 0. Job done. Didn't even need to write that, already written it once. How am I going to find the gradient of those first 2 graphs? Well, first things first, choose 2 defined coordinate values. So I'm actually going to mix it up, and I'm going to choose that one there, and I'm going to choose that one there. And I'm going to go across, and I'm going to go up. I'm going to do an arrow that way and an arrow that way because that's a positive direction and a positive direction. Thank you very much. Now, where do you think people get tricked in this screen? Shall I wait? Pause. Where do people get tricked? The axes. Now, if you look, earlier I said count squares. Don't count squares. Don't count squares. Make sure you know how many counting numbers you are going between there. Now, going across, we notice that we're going up in 1. So yes, each of those squares stands for 1. So I now know that that's 2 across. But if you look at the number of squares we use going up, every one of those squares stands for 2. And this was a huge trick to this question. So actually, we've gone 4 units up. Not squares, units. So my gradient for that first one, and I'm running out of room, is given by, remember, grade is rise, so the 1 over run, which gives me 2. And so my gradient for that line is just 2. Ka-ching. Can we now do the same for this one? Are they trying to trick us? Yes, a little bit. Why? Because there is a coordinate value there that I'm going to use, and I'm going to use them there. We've already used intercepts. We know the intercepts. I can use those. I'm going to draw a line. So I'm going to draw, here's my triangle so that I go across. That's positive, but hold on a moment, I'm going down. So that's got to be a negative value. Remember, it's going down. As we go down the y-axis, it gets more and more negative. Marvelous. So How many across have we gone? Well, I've gone 1, 2 across, because each square of those is worth 1. Is each square here worth 1? Yep. So 1, 2, 3 down. I've gone 3 down. So for that one there, the gradient is equal to rise. Oh no, that was run. What was I doing? So rise, which is actually -3 divided by my run of 2. And actually, that's how you would leave it. My advice for most of these questions is leave your answers as fractions. It's going to make life so much easier later on. Now, you can find the gradient using 2 points. I'm not really supposed to show you this formula for a while. So if you want to, I'll go on then, I'll do it. Another way of thinking about this is that my gradient, m, is y2 minus y1 divided by x2 minus x. What on earth does that mean? What's this y2 minus y1 business? Well, it's funny you should ask that. Because I have coordinates here, A of 3, 4, and B as 5, 6. Well, we know that's an x coordinate and a y coordinate, and that's an x coordinate and a y coordinate. Bit of a problem. In maths and algebra, if we choose something to be a letter x, it's got to be the same value all the way through, and I can't have an x of 3 and an x of 5, so I have an idea. Why do we call that x1 and x2 and y1 and y... So really, what this is saying here is that I'm looking for a difference between a y and a y. So actually that's a change in height. So this is just another way of saying rise. If I'm finding the difference in the y coordinates, then it's just a rise. And if I'm finding the difference in the x coordinates, then that must be a run. Now, lots of people will try and draw this. They'll actually sketch out a graph. They'll do the coordinate 3, 4, and 5, 6. But do we really need to? Well, maybe not. So let's have a see what we got here. So y2 minus y1. So I'm now going to substitute it into here. y2 from that coordinate was 6. I'm just reading off this value here. And my y1 value was 4, so I'm going to take away 4. I'm going to divide that by my x2 value, which is 5. And I'm going to subtract from that my x1 value, which is 3. And believe it or not, the rest of it is just child's play. 6 minus 4 is 2. 5 minus 3 is 2. And so my gradient between those 2 points is 1. Now again, if you're looking for a shortcut, just basically do the second y value minus the first y value divided by the first x value, the second x value minus the first x value, all right? And that realistically is the best way of doing it. Yeah, now I could draw a little pencil sketch. Sometimes it might be quicker to do that. I know the point 3, 4 could possibly be here with that 3, 4. The next one is 5. So there's my 5, there's my 6. Bit of a pencil sketch, join it into a triangle. Now, this is a more visual way of doing it. There's nothing wrong with doing that, because what do I notice? Well, I notice the difference between these numbers, 3 and 5, is 2. And the difference between those two numbers is also 2. That's a positive value. That's a positive value. So my gradient is equal to 2 divided by 2, which is once again 1. So actually, funnily enough, I still to this day draw little pencil sketches because it just makes life a little bit easier. But the quicker you get at this, the quicker you'll realize you can just do that 6 minus that 4, that 5 minus that 3. And make sure you do the order. You can't do the first, take away the second, and then the second take away the first. That doesn't make any sense at all. Now, I said at the start of the video, and again, this is a lot of information for this video. Some of you may turn around and go, nah, my head is exploding. Well, then stop. Come back to this later. Go back and watch it again if you need to. Download the notes and scribble all over them. That's what they're there for. Now, we can find the missing value of coordinates using my formula y2 minus y1 on x2 minus x1 is my gradient. So look at this question here. I've given you two coordinates, 0, 2, and 1 comma and something. We don't know what that is. And I want you to tell me, can you find this missing value here if I tell you that the gradient is 4? Well, now we go back to our algebra stuff that you should have done before. And our algebra stuff basically goes, what? Well, you can substitute. So there is x1 and y1. He says, writing that terribly. There is x2 and y2. So I'm now going to substitute what I know. y2, don't know what it is, going to write it as a question mark, minus y1, which is 2, divided by x2, which is 1, minus x1, which is 0, m. Why don't it? Oh, they told me m. They've told me that my gradient was 4. Okay, so now let's simplify, because with algebra, when you simplify. Question mark minus 2, don't know what that is. But 1 minus 0 is 1. Hold on a moment. Anything divided by 1 is the anything. So that becomes question mark minus 2 equals 4. And so in which case question mark would be equal to 6, because I'm going to add 2 to both sides. You see what I did there? Well, again, this is doing maths backwards. This is taking the information that you've been given, that formula here, this y2 minus y1, which is otherwise known as rise divided by run in a different way. And I'm just doing it backwards. Maths is awesome when you get your head around it. And believe it or not, ladies and gentlemen, that is the end of this video. Thank you very much for watching. Please subscribe if you can. Again, it just lets me know that you're watching. And tell your mates, you never know, there may be people out there who you know, even in different schools, who may well be struggling with this content. And maybe if my video made sense to you, it's going to make sense to them as well. But I'm going to call it a day for this video. There are lots more coming. Hopefully I'll see you in another video. You take care and please stay safe.